This is the video for section 11.6 Secant Angles. Please follow along with your video worksheet. The first section has all of the terms, definitions, and diagrams that I will be using, and the second section has all of the example problems that I will be showing you. Please fill in the worksheet as you watch the video. Let's begin. Secant angles are formed by secants or chords of a circle. The angle will either have its vertex inside the circle or outside the circle. Now in the first diagram we have two chords crossing so that they form an angle that we're looking for that is inside the circle. Whereas in the second diagram we have two secants and they form a vertex that is outside the circle. Now each of these two different situations will have a different formula that we need to follow. Now this table will help you decide which formula you need to use that relates the angle to the arcs of the circle. Now first, if the location of the vertex of the angle is at the center of the circle, we have what we call a central angle. And in that situation, the angle is equal to the intercepted arc. Now if the vertex is on the circle, for example with an inscribed angle, or any angle whose vertex is on the circle, our formula is angle equals intercepted arc divided by 2. Now if the vertex of the angle is inside the circle, this is a new formula today, we have the angle equals something I'm going to call arc 1 plus another arc I'm going to call arc 2 and divided by 2. And the last one we're going to learn about today is when the vertex of the angle is outside of the circle. Another new formula, the angle's measure equals the big arc minus the little arc divided by 2. Now use this table as we do the problems today and tomorrow, and they will help you remember the relationship between the angle and the arcs. Now in each of these example problems we are going to be finding x. Now x will sometimes be located at the angle and sometimes x will be located on an arc. In any situation you're going to be finding x. Now in this first problem we have two chords that intersect to form an angle. And that angle right here we are calling x. Now, our vertex is inside the circle. Whenever our vertex is inside the circle, we're going to be using the formula angle equals arc number 1 plus arc number 2 divided by 2. Arc number 1 is going to be our angle's intercepted arc. So in this situation, our angle's intercepted arc, x, is going to be this 170. So that's what I'm going to be calling arc number 1. Now, our angle's vertical angles arc, which is right here, I'm going to be calling that arc number 2 in our formula. Now in this situation, our angle is x, and then to find that we take arc 1, which is 170 degrees, and then we add to it the measure of arc 2, which is 60 degrees, and we take that answer and divide it by 2. Now to solve this problem I'm going to put the x over 1 and cross multiply. X times 2 is 2x equals 170 plus 60 equals 230. I divide both sides by 2 and I get x equals 115 degrees. Moving on to question 2. Now question 2 is pretty similar. We still have two chords and they're crossing to give us this angle we call x. Now this arc right here is x's, we call that arc number 1, and then x's vertical angles arc, we call that arc number 2. Now like I said, our vertex is inside the circle, and whenever the vertex is inside we use angle equals arc 1 plus arc 2 and we divide it by 2. So plugging in, our angle again is x, arc 1 is 106 degrees plus arc 2 is 174 degrees, and we take that sum and divide by 2. I put x over 1 and cross multiply. X times 2 is 2x equals 106 plus 174 is going to be 280. Divide both sides by 2, and x in this case is 140 degrees. Moving on to question 3. This one is a slight little bit different. We still have two chords crossing to form an angle, but in this case our angle is not x, it's 68 degrees. Our x is on its intercepted arc, so x is going to be in the arc 1's position. Then when we find the 68's vertical angle's intercepted arc, that's the 38 degrees, and we call that arc 2. So again, the vertex of our angle is inside the circle, and whenever the vertex is inside, our angle is arc 1 plus arc 2 divided by 2. Now our angle in this case is 68 degrees. The measure of arc 1 is x. The measure of arc 2 is 38 degrees, and we take that sum and divide by 2. Like the other problem, we put the 68 over 1 and cross multiply. 68 times 2 is going to be 136 degrees equals 1 times x plus 38 is x plus 38. Then we subtract 38 from both sides, and our x is found to be 98 degrees. Question 4 is a little bit different. The vertex of our angle is outside of the circle this time. Our angle, x, is formed by a secant and a tangent in this case. Now, since our vertex is outside of the circle, we are going to be using our second formula from today, which is angle equals big arc minus little arc divided by 2. Now, our angle in this situation is x. Equals our big arc. Now, as you can see, our purple angle cuts off two arcs. The first arc is going to be this one, the farthest one away from the angle, and in that case, the big arc is going to be 204 degrees. And now we always subtract when our vertex is outside the circle, and our little arc in here is the one closer to the angle. The little arc in this problem is 88 degrees. And then please don't forget to divide by 2. Solving this, we put x over 1 and cross multiply. X times 2 is 2x equals 204 minus 88 is 116. Dividing both sides by 2, we get x equals 58 degrees. Moving on to question 5. Again, very similar. In this case, we have two secants forming our angle. And our angle right here, this 19 degrees, is outside of the circle. So vertex is outside. And whenever our vertex is outside, we remember our formula is saying the angle equals the big arc minus the little arc and divided by 2. Now in this case our angle is 19 degrees. And our big arc, the one farthest away from our angle, is going to be 96 degrees. Minus the little arc is the one closer to the angle, is going to be x in this case, and divided by 2. Putting the 19 over 1 and cross multiplying, I get 19 times 2, which is 38, equals 1 times 96 minus x is 96 minus x. I subtract 96 from both sides, and I get negative 58 equals negative x. Dividing by negative 1 gives me x equals 58 degrees. Moving on to our last problem for today. In this problem, our angle is formed by two secants again. And our angle is outside of the circle, and its measure is x. So our vertex is outside the circle. And again, when that happens, the measure of our angle is the measure of the big arc minus the measure of the little arc divided by 2. Now, moving on to find our angle. Our angle is x. Our big arc is right here, the one farthest away from the angle, but we have a slight problem here. It's not given to us in this problem, so we have to go and find it. Now, in order to do that, what we're going to be doing is noticing that this green arc that I'm tracing right now is a semicircle. So it has measure 180 degrees. So to find the yellow arc, what I have to do is take the entire circle, 360 degrees, and I have to subtract off the 180 that I just found for my semicircle, as well as this little arc right here, which is 12 degrees, and also this arc right here, which is 23 degrees. When I do that, I get an answer of 145 degrees, and that will go right here, and that will end up being my big arc. Then I subtract my little arc. His measure is 12 degrees, and I divide by 2. Putting my x over 1 and cross multiplying, I get x times 2, or 2x, equals 145 minus 12, which is 133 degrees. Dividing both sides by 2 gives me x equals 66.5 degrees. This concludes the video on section 11.6, Secant Angles. Thanks for watching.